Global Finance, Topic 14C, NPV Terminal Values, copyright Lou Gaddis. So in this topic, we'll try to talk about how to use multiples and growth perpetuities to compute NPVs. And we'll calculate the present value of growth perpetuities and the present value of exit multiples. This topic is calculating, is the last of calculating NPVs. NPV is the present value of future cash flows. In the last couple examples, I had a finite number of cash flows. For example, I gave you the cash flow today and then cash flow in year 1, 2, and 3. You just take the present value of those 3 future cash flows. However, often an NPV requires an assumption about a future that goes on forever. So 2 ways of handling that is a growth perpetuity. In a growth perpetuity, you calculate the present value of the future cash flows. Say you might forecast 1, 2, 3, 5, or 10 years. And then at some point you get to a year in which you know, okay, at this point the cash flow is going to stabilize at some level and grow at some constant growth G, constant growth rate G. So at that point, and say I grow this for 5 years. So I estimate today's cash flow of F0. Then I estimate cash flows for years 1, 2, 3, 4, and 5. Now when I get to, say, year 6 out here, I'll say, well, at that point, I know that this cash flow is going to grow at some constant rate G. So this is a present value growth perpetuity. So if I take a cash flow over K minus G, it gives me the present value of a cash flow infinite series starting at this period and going on forever. This formula always gives you the present value or the value of those cash flows the period before. So if this were free cash flows in year 1, it will give me the present value at year 0. If this is the free cash flow in year 6, applying this formula would give me the value of the cash flow in year 5. Therefore, we always discount back the present value of a growth annuity for one period less than the cash flow period. So again, if this is the cash flow in year 6, I would discount it for 5 years. And the other way to handle this problem is don't make an assumption about constant or infinite growth, a constant infinite growth. What you do is you say, well, I'll estimate cash flows today and say years 1 through 5. And then at, say, year 5 or 6, I'm just going to say, well, the value of the entire enterprise, the firm, is going to be some multiple times the cash flow. So whether that multiple is 5 or 10 or 15, I'll say the value of the firm at that year is 5 or 10 times the free cash flow. And then I'll just discount it at that year. So I'm not reducing it by one period like I did up here. So here's an example. Facebook is evaluating an investment in a new venture. The investment will cost $900 million today and expect to return a cash flow of $100 million next year. And then free cash flows will grow at 15% for 2 more years and then grow 3% forever. So in this case, $900 today, $100 next year, grow that by 15 and 15. So here's the present value of the first 3 cash flows. This is my cash flow in year 4. And at that point, I know that it's going to grow at 3% forever, and I'm given that the cost of capital is 12%. So this term here would be the present value of all cash flows from year 4 and on, given as the value in year 3. So I'm going to discount that back at 3, and I get 452. A second way this problem could be done is to use a free cash flow multiple. So I have the same assumptions, cash flow 1, 2, 3, discount rate 12. This is cash flow in year 4. And then except in this time, I'm going to assume that in year 4, the venture will be worth 10 times the cash flow in year 4. So I'll just multiply 10 times free cash flows in year 4, discounting back to 4 years. In that case, I get 241. So those are the 2 most common ways to estimate terminal cash flow values or infinite cash flow values. And here I just threw this in as an example. Sometimes people say, well, what does it mean to have a terminal value, our free cash flow multiple of, say, 5 or 10? Because sometimes it's easy to think about what a terminal growth value is. Sometimes you can set it equal to, say, the growth of the economy. But why choose a multiple of 5 or 10? Well, here's just a little exercise that you could actually figure out what's the implicit, perpetual growth in our last example. So in our last example, we were using both the perpetuity model, cash flow over K minus G, and we used a multiple model where we took a multiple times the cash flow. So in that example, say that the cash flow is just $1. We had a discount rate of 12% and our perpetual growth rate, I'm just going to leave it at G, and we had a multiple of 10. So solving this equation, so what I'm doing here is I'm saying, well, if I use a multiple of 10 and I use a discount rate of 12, implicitly I can solve this equation and show that it's equivalent to having a perpetual growth rate of 2%. So again, it's going to depend on what the discount rate is, but it does give you an idea of how you can think about what a price multiple is. Now, more commonly, certain industries are known to have a certain multiple. So for example, you might say that an investment in tech, once you get to a constant growth rate, should have an evaluation multiple of 5 or 10 or 15. So certain industries might be known for a certain multiple. So hopefully we learned about how to use price multiples and growth perpetuities to value NPVs. And we calculated both the present value of growth perpetuities and the present value of exit multiples within NPVs.